What if Earth's axis were straight? A planet with no seasons. Right now, at this very moment, our planet is tilted at 23.5 degrees. That tilt is the only reason you experience winter, summer, spring, and fall. But what if tomorrow morning, every observatory on Earth reported the impossible? Our planet's axis had suddenly gone perfectly straight. No warning, no explanation. Just one morning, humanity wakes up to discover that seasons as we know them have vanished forever. Welcome back to the channel. Before we dive into this mind-bending scenario, drop a comment telling me which city you're watching from. And make sure you stick around until the end to discover what really happens when Earth loses its tilt. Because I promise you, the answer is far more catastrophic and fascinating than you might imagine. Let's get started. To understand what we're about to lose, we need to talk about what that 23.5-degree tilt actually does. Right now, Earth's rotation axis leans relative to the plane of its orbit around the Sunday. This seemingly simple geometric fact is responsible for almost everything that makes our planet habitable. The tilt gives us long summer days and short winter nights. It creates the tropics, where the sun passes directly overhead. It produces the midnight sun at the poles, and the dramatic seasonal migrations of countless species. Without this tilt, none of that exists. So here's our thought experiment. Imagine that through some impossible cosmic event, perhaps a collision with a Mars-sized object or some gravitational anomaly we can't even conceive of yet, Earth's axis suddenly rotates to 0 degrees, perfectly upright. Everything else stays the same. Our planet's size, its 24-hour rotation, its year-long orbit around the Sunday. Only the tilt changes. Now, I want to be crystal clear here. The sudden part of this scenario is pure science fiction. The laws of physics tell us this would require an absolutely staggering amount of torque, the kind of force that would likely sterilize the planet in the process. But let's assume, for the sake of this exploration, that somehow the axis straightens without completely obliterating everything. What happens next? The immediate aftermath would be nothing short of apocalyptic. When you suddenly reorient a spinning planet, you're fighting against something called angular momentum, one of the most stubborn principles in physics. Earth's core, mantle, crust, oceans, and atmosphere don't all turn together like a solid block. They have different densities, different viscosities, different moments of inertia. The result? Picture the worst earthquake in recorded history, then multiply it by 1,000 and make it happen everywhere at once. Every tectonic plate boundary on Earth would activate simultaneously. The ring of fire would erupt in a cascade of volcanic fury. Mountain ranges would shudder and crack. Cities would crumble. But the earthquakes would only be the beginning. The oceans have tremendous inertia. When the solid Earth beneath them suddenly rotates, the water doesn't immediately follow. It's like yanking a tablecloth out from under a full dinner setting, except the tablecloth is the entire planetary crust and the dinner setting is every ocean on Earth. The resulting tsunamis would be biblical in scale. We're talking waves hundreds of meters high, potentially kilometers inland, reshaping coastlines and drowning entire nations. Every coastal city on the planet would be obliterated in a matter of hours. And then there's the redistribution of mass. Right now, Earth bulges slightly at the equator because of its rotation and the way centrifugal effects work with our current axis. Change that axis, and you change where that bulge should be. Ice caps, ocean water, even the rock of the mantle itself would slowly begin shifting toward a new equilibrium. This process would take years, possibly decades, and during that entire time, the climate would be utterly chaotic. But let's fast forward. Let's assume humanity somehow survives this initial catastrophe, and we now live on a planet with a perfectly straight axis. What does daily life look like on this strange new Earth? First and most obvious, every location on the planet now receives exactly 12 hours of daylight and 12 hours of darkness, every single day of the year. At the equator, the sun still rises high overhead at noon, just as it does now, but as you move toward the poles, the sun never rises above a low angle on the horizon. At the North and South poles themselves, the sun would trace a perfect circle around the horizon throughout the entire day. Never rising, never setting, just endlessly circling at the exact edge of visibility. Think about what this means for temperature. The equator still gets blasted with intense, direct sunlight 12 hours every day. It's going to be hot, possibly hotter than today's equatorial regions, because there's no seasonal variation to provide any relief. Meanwhile, the poles receive sunlight at such a shallow angle that virtually no energy is absorbed. The Arctic and Antarctic would enter a deep freeze that makes current polar temperatures look balmy by comparison. And here's where it gets truly interesting. Ice is reflective. The more ice you have, the more sunlight gets bounced back into space instead of warming the planet. The more light you reflect, the colder it gets. The colder it gets, the more ice forms. This is called the albedo feedback loop. And on a straight-axis Earth, it would go into overdrive. Within just a few centuries, the polar ice caps would begin expanding dramatically. Not slowly creeping forward over millennia, but advancing at rates we could measure in kilometers per year. The ice would march toward the equator, swallowing Canada, Scandinavia, Russia, Patagonia, consuming latitude by latitude. If left unchecked, this process could potentially trigger what scientists call a snowball Earth scenario, where ice covers the entire planet from pole to pole. Earth has been in this state before, roughly 600 million years ago, and it took tens of millions of years and massive volcanic eruptions to break free from it. But let's talk about the middle latitudes, the zones where most of humanity currently lives. Places like Europe, the United States, China, Australia. On our tilted Earth, these regions experience beautiful seasonal variation. Warm summers for growing crops, cold winters for soil regeneration, spring rains and autumn harvests. On straight-axis Earth, that's all gone. These latitudes would experience a permanent climate somewhere between cool and cold, depending on exact position. No summer warmth, no winter frost cycles, just an endless, monotonous coolness. Year after year after year. Agriculture as we know it would collapse almost immediately. Wheat, corn, rice, all the staple crops that feed billions, all depend on seasonal temperature and rainfall patterns. Monsoon systems, which provide water for roughly 2 billion people in Asia alone, would fundamentally break down. The seasonal heating and cooling that drives these massive weather patterns simply wouldn't exist anymore. Rainfall would redistribute in ways we can barely predict. But one thing is certain. Current breadbasket regions would largely fail. This triggers a humanitarian crisis beyond anything in recorded history. Billions of people would need to migrate toward the equatorial band, the only zone remaining warm enough and wet enough to support large-scale agriculture. We'd see the complete abandonment of Europe, North America above the 40th parallel, most of Asia. Megacities would become frozen ghost towns. The entire geopolitical map would need to be redrawn. And it's not just humans. Every ecosystem on Earth is tuned to seasonal rhythms. Birds migrate based on day-length changes. Plants flower according to seasonal temperature cues. Predators time their breeding to match prey abundance patterns that vary with the seasons. Remove the seasons, and you remove the fundamental timing mechanism that orchestrates life across the planet. Species that cannot adapt to stable, year-round conditions would face extinction on a massive scale. Those that thrive in seasonal stability, typically equatorial species, would expand their ranges. Over thousands of years, you'd see a complete restructuring of global biodiversity, with a dense ring of life clustered around the equator, thin transitional zones in the mid-latitudes, and vast, sterile ice deserts at the poles. But let's go even deeper. Let's think about what this does to human culture and consciousness. Our entire conception of time is built around seasons. Spring represents rebirth and renewal. Summer means growth and abundance. Autumn brings harvest and preparation. Winter is death and dormancy, followed by spring's resurrection. These aren't just agricultural concepts. They're woven into our religions, our literature, our art, our philosophies, our very psychology. Remove the seasons, and you remove the physical foundation for countless cultural traditions. No more winter solstice celebrations marking the return of light. No spring fertility festivals. No autumn harvest festivals. No summer celebrations of abundance. Calendars would lose their weather-based meaning and become purely orbital, tracking Earth's position around the sun without any corresponding change in daily experience. The night sky itself would become more static. Right now, different constellations dominate different seasons. On a straight-axis Earth, the view from any given latitude would barely change throughout the year. Astronomy from the ground becomes less dynamic, less poetic. Humanity would have to rebuild its entire temporal framework from scratch. New holidays would emerge, perhaps based on orbital positions rather than climatic shifts. New myths would arise to explain a world without seasons. New philosophies would develop to make sense of endless, unchanging patterns. The human experience would fundamentally transform in ways that ripple through every aspect of civilization. Now, you might be wondering, could this actually happen? On a scale of 1 to 10, where 1 is nearly impossible and 10 is common, a sudden flip to 0 degrees tilt rate's about a 1. It would require a planetary collision on the scale of the impact that formed our moon, or a close gravitational encounter with a massive rogue object passing through our solar system. Neither scenario is likely within any time frame relevant to human civilization. However, Earth's axial tilt does change naturally over time. These are called Milankovitch cycles, and they're responsible for triggering ice ages. But these changes are small, oscillating between about 22 and 24.5 degrees over periods of 41,000 years. Life has time to adapt. A sudden shift to 0, that's firmly in the realm of science fiction. But here's why this thought experiment matters. It reveals just how extraordinary our current situation actually is. That 23.5 degree tilt isn't just a random geometric fact. It's one of the fundamental reasons Earth is habitable. It gives us climate diversity. It drives ocean and atmospheric circulation in ways that distribute heat and moisture across the planet. It creates the seasonal rhythms that allow complex ecosystems to flourish. It provides the temporal framework that allowed human civilization to develop agriculture, permanent settlements, and eventually, everything we call modern life. When we look at exoplanets, planets orbiting other stars, one of the things astrobiologists consider is axial tilt. Too much tilt, and you get extreme seasonal variations that might make life difficult to establish. Too little, and you risk the kind of climate stratification we've been discussing, with uninhabitable poles and a narrow equatorial habitable zone. Earth's tilt appears to be in something of a Goldilocks zone. Not too much, not too little, but just right for a thriving biosphere. So the next time you complain about winter cold or summer heat, remember this. Those seasons you're experiencing are actually a sign that you live on a remarkably stable, remarkably habitable planet. The tilt that brings you snow in December and heat in July is the same tilt that makes complex life possible, that creates the climate zones supporting vast ecosystems, that gives humanity the predictable patterns we built our entire civilization around. In our imaginary straight-axis Earth, survivors would look up at the unchanging sky and dream of a time when the world had rhythm, when nature followed cycles of death and rebirth, when the tilt of the planet created the beautiful complexity we so often take for granted. If you found this exploration fascinating, make sure to hit that subscribe button and turn on notifications so you don't miss our next deep dive into cosmic what-ifs. Drop a comment below telling me what other impossible scenarios you'd like us to explore. What if the moon suddenly disappeared? What if Earth's rotation stopped? What if we lived on a tidally locked planet? The universe is full of these thought experiments, and each one teaches us something profound about the razor's edge we occupy in the cosmos. Until next time, keep looking up, keep questioning, and keep marveling at just how extraordinary our ordinary planet really is.